Hey folks, my name is Johnny Tyers, and welcome to my talk. We're going to be talking about threat modelling. Before I get cracking, I just wanted to say a big thank you to the organisers of 90 Days of DevOps. It's been a great series of talks and information so far. I've certainly been getting a load out of it just as listening. And it's even more of a privilege just to be able to come here and speak to you and share my experiences. So I hope you get loads out of this talk, and I hope you've been getting loads out of it so far. Just a big thank you to the organisers. Thank you for putting it all together. It's a huge amount of work, and I'm really grateful. So my name is Johnny Tyers. I'm just going to talk a little bit about threat modelling and putting risk at the middle of security. Firstly, a little bit about myself. So my background is when I was a teenager, I was indeed a hacker. So I've sat on the other side of the table and been a bit of an adversary. After getting caught and going straight, best thing that ever happened to me, by the way. I spent a long career in application development and security. Moving into infrastructure and cloud, and then 7 years ago founded ThreatPlane. And I'm the managing director of ThreatPlane. We are a small group of cybersecurity consultants who work with businesses to put risk at the heart of their security strategy. And threat modeling, which is what I'm going to talk to you about today, is what we do day in, day out. We have lots of stories of success stories, customers where they've their security, their culture around security, their understanding, and even the way that they develop has been kind of revolutionized by this approach. It's just really helped them get going with it in a really good way. So first, let's talk about some context in which we operate. None of this will be new to you, I should think, but it's worth just reminding ourselves. So development is more complicated now than it ever used to be. It is. The first thing is that there's more pressure than there ever was. Features are being developed faster, things are moving quicker, the infrastructure that we develop on top of is moving quicker, and complexity generally is just on the up. You know, we're dealing often with cloud, but also with hybrid environments, with on-prem environments in some businesses. And even if you're only in the cloud is an incredibly complex environment to be. I've lost count of how many exactly AWS services there are, but it's certainly getting around the 300 mark. 300 AWS services, and that's just one cloud provider. It's just mental. So there's a lot of complexity out there. Obviously, all those services are also changing all the time. There's new features, there occasionally are deprecated features, the best practice evolves, all that stuff. So cloud is very complex. Got a lot of things going for it, of course, but it's very complex. The other challenge is that the risks are unknown. So although we know about the technology risks, and we'll talk a little bit about that in a minute, at the same time, often the risks that are facing businesses in terms of cyber are unknown. No business really knows which attacker or group is going to attack them next. They don't know what that group is doing today. We can get threat intelligence that tells us what they've been up to recently, that tells us, the sort of things they're up to, but it doesn't conclusively give us information on exactly what's going to happen, and indeed when or where. Often breaches are a total surprise when they're discovered, but actually they've happened a long time before. SolarWinds is a good example of this, where the hackers were in the infrastructure in the SolarWinds infrastructure for, I think it was 9 months before they were discovered, and that's not uncommon. A dwell time of many months. So it just goes to show the challenge of facing teams who are addressing this. Security is complex. At the same time, strictly on the cyber side, things are challenging as well. So we're spending more and more on cyber every year, and that is still the case. People were talking about this happening. People like Gartner and stuff were talking about cyber spending going up. Years and years and years ago, it was the next hot thing, and there was a bit of a hype cycle around it. But now, cyber spending is still going up because now it's such a big risk. Technology, I often say, is the biggest risk facing any business today, because the vast majority of businesses are dependent on technology one way or t'other. And obviously, for everyone watching this, we're all running infrastructure, developing applications for the organizations we work for. All of those are going to have business importance of some sort, whether it be generating money, whether it be compliance or whatever. And at the same time, this graph on the left shows the disappointing side of the story, which is that although cyber spending is, these last 2 years on the right are good, projections, but is almost doubling. That's not reflected in the cost of breaches. So this study was done by IBM not very long ago, and as you can see, the cost of breaches is actually going up. So, and this is just data breaches. This is not, all cyber attacks by any means. It's just data breaches, a single data point. But as you can see, although spending is rapidly going up, we're not actually getting more efficient or sort of more streamlined at addressing security breaches. The costs are either flat or increasing. Then, just another nod to the complexity. All of this will be very familiar to all of you around the table here. I'm sure this is the CNCF landscape diagram as of a few months ago. And it just gives you a flavour of the complexity of the environments that we operate in. We've got cloud providers, we've got orchestration layers, we've got networking plugins, we've got all of the Kubernetes ecosystem, we've got observability and monitoring, we've got deployment platforms, we've got key management, we've got encryption, we've got deployment manifests, we've got databases like etcd, we've got service meshes. There's so much stuff going on here, and the average tech stack that you or I develop with today and fit into is just horrendously complicated compared to what it was many years ago, where the challenge was very different, the tech stack was very simple. Today there's an absolute mind-numbing kind of maze of different technologies that we work with. And of course, our application is not in isolation. Sometimes we might feel as teams that we're in isolation, but our application certainly is not in isolation. We need to be connected to all this, and our application, which is important to the organizations that we work for, important to our businesses, it needs to be connected into all this somehow. And the big challenge that we've got with security at the moment is that you've effectively got two different trajectories. You've got security going one way, and you've got the business doing their thing and kind of going the other. And the sort of symptom of this is that security today, often the language of security is technology focused. If we're running a team and we're in a team together, and someone asks the team lead, "Hey, so have you thought about cyber for this stuff you're doing, this app you're building?" And they go, "Hey, yeah, so guys, what about cyber?" And we all think, right, what are the security things we've got? What we're going to come up with is, well, we've turned on IMDS-v2 in our EC2 instances. We've enabled TLS across all of our external endpoints. We encrypt all the disks, and we encrypt all the data that goes across our wires. We use auto-scaling groups to ensure resilient infrastructure. We, and so on and so forth. We've enabled MFA in the AWS console. All of these are technology things. They're all point solutions. And they all have value, sure, but to a non-technical person, to the kind of business that sits around us, doesn't make any sense. Whether we've got MFA enabled or not doesn't really tell us whether actually the business has got a lower level of risk or not. You could have an application that's got MFA enabled but be full of vulnerabilities. Doesn't make any difference if MFA is enabled if it's full of vulnerabilities. You could have a cloud environment that is totally secure by the standards of the cloud provider, follows all the best practice, but if you've got buggy application code that doesn't properly authenticate users, you're running far bigger risks. So the technology story alone does not fully tell us where the security angle is. And of course, what the business is interested in is what risks are we running. And when we think about what risks we're running, we're thinking about business outcomes. This thing on the right, the thing that the business is doing. The business is trying to grow. It's trying to get more revenue. It's trying to keep a handle on its operating costs. It's probably trying to stay compliant with some legislation or some regulatory regime that it's operating in. If they're pre-revenue, then they're a startup, and they are they might be dependent on their investors for funding. Their investors might be doing due diligence, all those sorts of things. So so there's a number of things that the business is doing that are totally divorced from what the security team is thinking about. And what we want to get to is a place where we're unifying, where we're kind of going in the same direction. And interestingly, the business is going to take a bit of an erratic path here. And if your founders, your senior in your business, you'll know this, that businesses, the path they take is usually erratic. The business changes, the competition changes, the people change, the market changes, investors give you a new sort of area of focus, a new customer comes along who totally turns upside down what your business is. Businesses pivot, they take handbrake turns, sometimes very quickly. And it's kind of reflected here really. And it's our job as security practitioners, but also as technologists generally, to do that journey with the business. It's going to be critical to the business, the technology that we're building and the security thereof. Therefore, we need to be on that same path with them, so that the business kind of knows it's supported, but also so that we're all just aligned in the first place. So this is kind of the summary of all that section, really. We start in this, and for threat playing, what we do is we have a brochure that we often give to people or email over. The first page of the brochure is this. It's exactly this. It's technology focused. This is where you are today. And although technology is obviously beneficial for security, if we focus on the technology, we're going to be kind of down in the doldrums. It's going to cost us. Because what that means is that it's all about jargon. And if you don't understand the jargon, you don't understand the security. It's not necessarily aligned to the business because it's all technology concerns at that level. Therefore, it's going to be difficult to relate to the business goals and the context. It's going to be siloed from whatever compliance efforts are going on because compliance is generally a business function. And interestingly, it will slow technology change as well. So I don't know if you've ever had this in your teams where maybe you're building a new feature and you're exposing, a new API to the world, and you are thinking, well, do we use this technology or that technology? Maybe the cloud provider's got several different services you could use. Maybe you've already decided that, but you don't quite know how to authenticate the clients that are going to be sending you API calls. Or maybe it's a public API, but you need to have some way of managing the data that's coming in to make sure it doesn't get abused. Or maybe you need to have a patching strategy, and you know that, but you don't know how often we should patch, things like that. And it doesn't take many of those security questions for the uncertainty alone to just slow everything down, because basically the ticket gets stuck. It's like, well, we don't really know what service to choose. We don't really know what standards to apply. We don't really know, what decisions we should be making because, many of us who are working in DevOps are not security trained. We're not security people. Our skill set is broader than that. So you can just end up with work being slowed down purely because of the uncertainty, let alone the fact that security might, also, introduce a lot of challenges on its own. Often technology-focused security sort of organisations that are purely focused on technology side of security also make you jump through hoops which are kind of aimed to get you to what they would call 100% security, the kind of perfectly secure panacea. And what we know is that that's not really true. You can't be 100% secure. But businesses will try and do that. And of course, that can be quite difficult, a lot of work. Where we want to get to is the risk focus. And really what I mean by that is business risks, by the way. So think about risks, but in the context of the business, not the technology. So things like revenue, things like reputation, things like operations. Are our operations running or are they not? Are they degraded or are they not? And compliance is often the big topic as well. So are we compliant with all the things we need to be? How compliant are we? What are the consequences if we're not? Are we? Is there a grace period where we can afford not to be compliant for? All those considerations around the compliance piece. So security, I believe, needs to play into all of that. It needs to be phrased and communicated in the context of those business risks. So, and that means that we get language the business understands, because now security is aligned to business risk. It means that security and business, in terms of where they're going, their strategy and their sort of ultimate goals, are aligned. As I say, it can contribute to compliance efforts. And because now this uncertainty thing that I talked about a minute ago is gone, instead of uncertainty, developers have confidence, because now we know where the standard for security is. We know in our tech estate where the big risks are and perhaps where they are not. So we know where actually different solutions have different viability in different parts of the infrastructure as far as security is concerned. And the other thing is communication. So I'll talk a bit more about that in a minute, but security, risk-focused security tends to aid the communication of security. So what is threat modeling? Into this kind of quagmire that I've laid out for you, which we're going to fix, is threat modeling. How do we, What is threat modeling? So threat modeling aims to do a few things. It is primarily a discovery tool. It is there to help discover threats and sort of by implication, the things that we need to do about those threats. Number two is it communicates. So the communication side of security, I think, is often lost on most people and is not seen as that important. And I've written a blog post or filmed a video about this on my LinkedIn profile. I think the importance of communication in security is just so important. If even for users, if you properly communicate to a user, so say the user hits a roadblock because of a security thing, they can't log into, say they're using a system from a cafe, a Wi-Fi hotspot in a cafe, and security says no. And there a message comes up saying, nah, can't do it. The user's like, what? That's annoying. I'm trying to get my work done. I'm going to try and work around it. I don't understand why. Why can't I just use it? That's annoying. What if you had the same scenario, but instead of security says no, you had a, I'm afraid you can't do that because the risks of you operating in a cafe on a Wi-Fi hotspot are just too big, so we can't let you have access to our internal corporate data from that location. If you want to go down the road to the office and plug in there in a sort of secure environment, then that's fine. The user's going to have a totally different reaction to that because they're like, okay, it's still annoying, but now I understand why. Okay, fair enough. And the communication aspect of security is really important. The same is true in development. If you have a security team who puts limitations around what you can do in your cloud environment, that's frustrating. It slows you down. It prevents you perhaps from doing your job. Your instinct is to try and work around them, if we're honest. Often you succeed because developers know the environment's best often, and that can just clearly that's a recipe for disaster. Because security now doesn't really know what the true security position is. Developers have taken risks in order to meet deadlines. You have this kind of uncertainty factor. So security is a communications tool. Threat modeling, is a communications tool for security, I think really helps with that. The third thing is that it's all about collaboration. So threat modeling at its core is just a workshop. It's a workshop session and a joint journey where we go to discover threats and the related risks. I'll talk about that more in a minute. So the key components of threat models are threats, risks, and controls, which feed into all these categories. And where can you use threat models? So the answer is wherever there is risk. Threat models are great because they're so flexible. You can use them on new systems. So you might build a fresh new platform, and we can threat model that. But you may also be sitting on an estate full of legacy technology, which is complicated, not all of which you understand. We can threat model that too. And that's the beauty. You can even threat model systems that don't exist yet. So, we've had back of the envelope style designs, which we can threat model, because if we've got enough detail, sure, it's not going to be as detailed as a full threat model of the full design once it's implemented and stuff, but really useful to threat model at an early stage to determine the viability of different things. And we have done engagements, where you threat model early to work out, actually, would it be too hard to architect this system that way because actually the security has to be really high because of the way we've architected, versus this way where we might change the bits of the architecture, which means that actually the security is lower because there's some natural segregation there. For example, that was a real example. So the other thing is that you can threat model what you like. So you can threat model a system in full, or particularly if you're listening to this and you're thinking this threat modeling stuff sounds interesting, but we can't just move our whole organization to threat modeling overnight. You might say, well, let's dip our toe in the water. Can we threat model an individual system or an individual component or feature and say, let's just threat model that thing and see how we get on with the process and work from there, and sort of hopefully gradually get to a place where everything is threat modeled. So it allows you to sort of test it out. And also to, often with our customers, we don't go in and say you need to threat model everything. That's just not realistic. But to say, where are your biggest risks likely to turn up? Right, let's go there. If your e-commerce is going to be your website, if it's your banking, it's going to be your sort of ledgers and your back-end systems. So it's wherever the risks are deemed to be biggest. And again, this is business risk. Where do you earn your revenue? Where's the compliance burden, and those sorts of things. So choosing where to threat model can be quite an important set of decisions. The other thing is that threat modeling doesn't have to be all technical. You can threat model things that aren't technical, like a business process. You might even look at data flows that aren't technical as well. So thinking about like a supply chain map, for example, flows of data between different suppliers that link to your business. You could threat model that. No reason why not. The other thing about threat models is it can really fit into whatever current security structure you've got in terms of things like processes and documentation. So I often say that it can complement other security documentation. If your threat model, ideally, if we go to this bottom one here first, threat models evolve as systems evolve, ideally. So when you're threat modeling, you can keep your threat model up to date as your system evolves, and that tends to take two forms. Either you literally threat model as you go. As you're doing sprints, you have quick threat modeling sessions that threat model new features, so that you can just build that into your threat model and thus keep the threat model up to date as you develop. Or you can just do a regular review. So you can say, we've built a threat model, let's every quarter check it's up to date, or every year check it's up to date, or on every major release we check it's up to date, something like that. So given that threat models ideally evolve as your system evolves, it then follows that, threat model becomes the real-time kind of accurate view of security in our system. So actually, it's a really helpful way to inform the other security processes we have in our organization. Risk registers, general risk and compliance. If you've got an information governance team and requirements around that, you can use your threat model to answer the questions that those teams have. Really useful stuff. And as I've already said, threat models are very flexible to produce, and you can move their scope around. So what makes up a threat model? The core of a threat model, the guts of a threat model, are made up of three things. I've talked about threat controls and risks already. The thing that we'd stick in front of that is the scope. And the scope is like think about it like sort of a high-level design for your system. We also call it a DFD, a data flow diagram. And really what we're after is a kind of a boxy diagram that shows where are the components, what data flows between them, and things like where are the integration points, where are the data stores versus the users and the sort of processes that sit in the middle. That is the core of a data flow diagram. It doesn't have to be, it can be, but it doesn't have to be a full architecture diagram of your system. And as I've said before, it could also be a back of an envelope, so it could be quite high level of, this is what it looks like. Generally what we go for with DFDs is simplicity. So we say it needs to be as simple as possible, but as complex as it needs to be to faithfully represent the security and the risk concerns. So, that's kind of what we're going for with DFDs. We've already talked about threats and controls and how they fit into a threat model. You could also add, as I've already said, you could also add risk. I would say you must add risk. Many places don't. Threat modeling has been practiced for a long time. Historically, does not include risk. And my message to you today is include risk. You'll just have a far more valuable document. The conversations you'll have if you ask about risk will be far better than if you didn't. But you can also add other things as well. You can fold in security standards and frameworks. You can think about your controls and also how current the controls are. Controls testing will be part of that as well. You can also think about your monitoring use cases. We certainly do as a matter of course. We find that's a really important part of the threat models we deliver. You can think about inherent and residual risks, levels of risk, and finally CTI, cyber threat intelligence. Not mandatory, I'd say, for threat modeling, but can be useful in some sectors. So, how do we create a threat model? A threat model, as I said before, is basically a workshopping session. And that's not to undermine it. That is to say, actually, it's brilliant because it's flexible, it's collaborative, it's people coming together, it's a creative time. Ideally, when we do threat modeling for sort of fresh threat models, so things that haven't been threat modeled before, we recommend a 60 to 90 minute session. Sometimes you need 2 sessions. It depends on the scope and how complex it is. And you don't really need a security SME, but what I would recommend, I mean, if you don't have a security SME, by the way, definitely get one to review your threat model before you go live if you can, just to make sure that you've got some kind of sanity check there. But in order to perform the threat modeling itself as a first pass, don't necessarily need a security person in the room. It's helpful to do it even if you don't have a security person in the room, is what I'm trying to say. But what is important is to have this threat modeler here. So this is just someone who's done it before. They act as the facilitator, the chair of the meeting, if you like. So they're just there to guide the conversations, to give it a bit of structure, and make sure that we're sort of focused on all the right things. The other thing is your engineering team. So typically when you're threat modeling, you are threat modeling a technology system. So the team that understands that system, how it integrates and the components that make it up, some of the detail, that's really important. Inevitably you find that there are things in your DFD that there are things that aren't in your DFD that you need to include, and you only discover that when you're speaking to engineers in a threat modeling session. You're like, okay, yeah, there's some extra detail we need to add in here because it's important. So yeah, really important to have engineers there. I'd also recommend having more than one. Ideally 3 or 4. Doesn't have to be the whole team, but ideally 3 or 4 engineers. That's the number. And the reason for that is that often engineers have different specialties. Particularly in a bigger team or a bigger system. You're going to have different specialties. Some of you are going to be more familiar with the networking, for example. Some will be more familiar with the IAM layout. Some will be more familiar with the application side, some with the infrastructure side, and so on and so forth. They're all going to have specialties, just areas that you've worked more in. And a big part of running a DevOps team is trying to make sure there isn't an imbalance in that knowledge. But inevitably, engineers have different specialties and different interests. That in itself is not wrong. So we just want to make sure that's represented in the threat modeling session. The other group that I would try and include is business users. It's not always possible to do this, but where you can, you should. Business users are just anyone who is either using the system, i.e. they are literally a business user, or they are someone in the business who represents the user. It might be pre-sales, marketing, or your sales team, or someone else. It's important to have that because they just bring the user's perspective. They usually also have a good handle on the business risks and where they turn up. And also on that sort of, often we have this kind of chasm, don't we, where we say, this is how we have our system and our feature set, this is how we expect it to be used. And then the user comes along and says, yeah, but this is actually how it's used. And you need that perspective in a threat model because it's there to be a realistic document. So you want to make sure you captured that view. So, but yeah, as a minimum, make sure you've got some engineers there. As I say, ideally more than one, so you're getting multiple points of view, a sort of fuller understanding, and someone who's done threat modeling before. And then we go into the 6-stage process of building a threat model. So very briefly, all the things that I've already talked about around scope. So we aim for scope as simple as possible, as complex as necessary. And again, necessary means just including the things which we know will be important from a risk or a security standpoint. That's generally the criteria. So determine your scope. And then these 2 categories are just there to help with context setting. So we usually at this point say, right, what data are we dealing with? Typically, in many contexts, there's some level of personally identifiable information. How personally identifiable is it? Is there other data that we're dealing with? Particularly, if you're in a legal firm, you might be dealing with commercially sensitive, sort of legal documents, or things that have strong confidentiality requirements around them. Data which is not yet to be released. One company we work with works in the medical sphere, so they're working with electronic health records. DNA data, things like that, and then finally threat actors. So we don't need to know exactly who the threat actors are. I'm not expecting to know your APT10s from your APT29s, but it is helpful to know the sort of threat actor that you think you might be up against. How valuable is your data? Is the average attacker, is the sort of attacker that you think might target your organization going to be resourceful? Are they going to be really motivated? Are they going to, might they be quite sophisticated? Might they be trying to play the long game? Is that sort of consideration. It's just as a rough order of magnitude in the air. where are the threats coming from. One important angle to consider for that is insiders, both malicious insiders and accidental insiders. So, particularly with cloud environments, it can be possible to do things accidentally. Grant privileges accidentally, destroy some infrastructure accidentally, whatever. So capturing some accidental instances of privileged use is important. And also, obviously, the malicious insider angle is just generally important. That tends to be where the most serious attacks come from, is involving some level of malicious insider. Anyway, so and then the last stages of the threat model are more involved. First, we look at brainstorming threats and discovering threats using, we're going to use Stride. I'm going to take you through Stride in a minute. We can also talk about controls at this point. So usually after we've done the threats, we focus on controls, and then we rinse and repeat. And when I say repeat, this is that living document thing. So repeat when the system changes, or repeat when, on a fixed cadence, whatever your preference, but make sure that you keep the threat model up to date. Really important. So let's talk about Stride. Stride is a sort of guidance, acronym that sort of helps just acts as a category really for different attacks. In my experience, so Stride doesn't aim to capture every kind of possible attack. There are other frameworks that do that. Stride doesn't aim to do that. What it aims to do is act as a bit of a guideline as to what sort of attacks you might encounter. In practice, what I've found is that all the threats that we capture in a threat model can fit into one or more of the Stride categories. And Stride stands for these words here, and I'll just step through each of the categories just so you get a feel. So spoofing is all about impersonation. So can a user impersonate another user? Could an attacker impersonate a particular VM? Could an attacker impersonate on-prem, connecting to the cloud? Could we impersonate the database and fool an application into connecting to us and giving us its data? That sort of thing. Tampering is all about fiddling with data. So fiddling with data on the wire or at rest. So being able to read data off the wire, like intercept network packets or something similar, and make changes to them, or at rest. So reading data directly on the disk of a machine or whatever, and tampering with it that way. We'd also include things like source code tampering in this. So someone being able to tamper with source code, upload something to a Git repository, have it fed into a merge request or a pull request, run by a pipeline and then deployed. That would be an example of a tampering threat where someone's able to deploy malicious code through that flow. And then we've got repudiation, which is generally around auditing. So that's either someone claiming that they've not done something when they have, or claiming that they have done something when in fact they haven't. So those are the two threats. And generally it comes down to the strength of your auditing trail. Not only audit trails, but also we include threats around the audit system itself there, attacks against the logging system, generally under repudiation. Fourth is information disclosure, which is your basic data breach, right? So this is all about just an attacker gaining access to information they shouldn't really have access to. Denial of service is any kind of degradation or outage. I'm sure you're all very familiar with denial of service attacks already. Often a key risk in many businesses, surprisingly so. Sometimes it's the most important one in businesses where you don't expect it. Denial of service. And then finally is elevation of privilege. Elevation of privilege is like the queen of Stride, I often call it. So elevation of privilege is like someone getting root on your VM, or getting your production credentials and from there is able to do things. And generally, if you've got elevation of privilege, you're able to conduct any of these other attacks. So if we find an EOP threat, an elevation of privilege threat, that's going to be the most serious one generally. Obviously, there's a caveat to that, which is where you find the elevation of privilege threat might be in a low risk area of your system. So, it's not always the most serious, but generally EOP threats are going to be the most serious. After threats, so before I jump into controls, so how we do this with Stride is that we iterate through every part of the DFD. So we say all of the components in our DFD, the users, whatever cloud infrastructure you might have or anything else, the processes, the data stores, the flows of data. We iterate. The easiest way to threat model is just to iterate through all of Stride for each of them. That there are other methods to they're a bit more streamlined, but that is by far the easiest, and just go through each one and say, are there any spoofing threats? So if I have a Lambda function, which is serving an API endpoint, I might say, maybe it's authenticated. So immediately the question would be, well, can I spoof an authenticated user? If I'm an attacker and I'm not allowed in, can I pretend to be a user that is allowed in? Can I brute force their password? Can I steal their MFA? Is there a session token I can steal? Is there, is there any authentication at all, or is it really weak? Those sorts of things would be spoofing. And then you go through that for each of the other categories. So tampering, repudiation, information disclosure. Are there bugs in our application which could divulge information when it's not meant to? Are there weaknesses that could cause an outage? That sort of thing. So you iterate through that for all of your DFD, and then we move to controls. So controls are brilliant. Sounds awful to say that, perhaps if you've had an experience of controls in a modern organisation, but the way that we do it, it's great. So controls are any way to detect, mitigate, respond, or prevent the threat. So it's just, what are you going to do about it in the widest possible sense? And the great thing about controls is that really it's a blank canvas. So when we get to this part of the threat model, we want the sky to be the limit. We encourage always DevOps teams to be really creative with their controls. So just think of anything which could, no matter how weird, could prevent this from happening. Because you might find actually there are some real gems in there. Sometimes we find there are some really kind of easy controls that we can put in place that don't cost the earth to implement or don't require a fancy solution or whatever. So a good example of that was with a customer some time ago, last year I think, where we had they had a code base that was running the access control for their cloud environment, so all the policies and stuff, and it was a repository driven by Terraform and CI/CD, and the code was a bit of a mess. It worked, it did the access control correctly, but the risk was, well, one of our team might, make a change and inadvertently break something, either deny access to someone, which would be kind of denial of service. Other teams can't maintain their apps. That's probably quite critical, or open up access where it's not meant to. So suddenly people have got access to data they shouldn't have, and malicious insiders, all that stuff. So there are lots of controls we thought about. Could we run some, wrap it in a test framework, make sure that, could we restructure all the code? Could we do KT, like knowledge transfer sessions with the team? Lots of different things like that. And all of that was, well, that's great, but this is a major risk and we've got to go live in like a month. So, none of that is practical in a month to sort of address the risk. What can we do? In the end, we said, well, let's just have a change freeze. So we don't change any of the code, which means that the threat won't come in. Now, we're not saying you don't need to do the other things, but what we're saying is, for the time being, you can just have a change freeze. Really simple control, costs nothing to do, and addresses the risk for now. Obviously, we're not here to cut corners. You need to actually address the issues underneath, and there were some issues in that case that needs to be addressed. But a good example of just simple control to address the risk. Hopefully, you get what I mean. The other thing is, as I've just demonstrated, really, controls don't have to be technical. If you can think of a business process or human kind of way, cultural way perhaps, of fixing a risk, then you should certainly look into that. An obvious one with insiders is, if you're thinking about accidental changes, is code reviews. Not foolproof, but certainly help. Another one might be vetting people, so saying, well, we can only let you manage our DNS infrastructure if you actually understand DNS. And if you don't, then, maybe we do some training or some knowledge transfer or something first. And, in the more general sense for malicious insiders, many companies already have employee vetting programs. Are you fit to do this job? And, that could form a control in a threat model as well. I keep flipping my screen, sorry. And the last thing is capturing controls in place. So really helpful to capture controls that you already have. All of you will have had security in your minds already, probably, when developing the solutions that you are. And threat modeling is a communications tool, as we've already said. Really, really important to capture all the good work you've already done. That does a couple of things. Number one is you've now got a document that says we've already done this stuff. You've got a way of claiming credit for it. And I'm sounding flippant, but that's really important. It keeps us all motivated, and the rest of the business can see, no, actually they've done a lot of good work here. So it's important to make sure you're recognised, that the threat model recognises the work you've already done in security. Number two is, which is just as important, is that you accurately reflect the risk. So if we discover a threat in a high risk area of the system, like red warnings, flags going off, high risk, but actually there's already control 1, 2, 3, 4, and 5. The team have already done. We've already blocked off the firewall port. We've already enabled MFA. We've already encrypted this, and we've already done that. Then actually, although none of that was captured during the threat modeling, it was all stuff that was already in place. It still reduces the risk. So you want to make sure that that's captured so that you have a fair reflection of actually what the level of risk is. Absolutely crucial. So make sure you capture controls that are already in place. You could also include other things in your threat model, as we've already said. Don't forget to think about business risks. You could look at standards and frameworks. AWS well architected might be a consideration, or CIS, NIST, whatever. Control status we always do as a matter of course. So thinking about just the status of your controls. But also on the right here, some more exploratory things. So if you have a CTI function in your business, you've got access to cyber threat intelligence, there might be some value, emphasis on might be some value in including on the threat model. Just a word of warning here with things like CTI. The whole purpose of the game is to move to the business end, not the technology end. That's number one. Number two is that threat models need to A, reflect the risk, and B, need to be simple. If you include CTI in your threat model, that's great, but number one is CTI is all about technology, so you run the risk of kind of undermining that whole business side, because you're saying, there's no risk because the attacker groups are doing X, Y, and Z, and outside stakeholders are going to struggle to understand that. And number two is that CTI doesn't tell you what's going to happen. CTI tells you what's already happened, and it tells you our understanding about what we know about what's already happened, which is not the full story. So, CTI has some clear uses, but there's also some clear limitations. So I'd really caution anyone who's using it as a strong indicator of risk in their threat models. Just be aware of its limitations, and don't let it hijack your threat modeling. The other thing is, of course, that CTI changes all the time. Hackers are doing new things all the time. If you include it in your threat model, what you're basically doing is committing yourself to the burden of always updating your threat model, because the CTI will always be changing. So that's the other reason that I'd caution against it generally, is that it does, it just suddenly means that you have to be updating your threat model daily, and that's just generating work with no real benefit, because, as I say, it only has a tangential bearing on the real level of risk. So so I hope that's helpful. Thank you for watching. That kind of comes to the end of our session. Hopefully you've got something practical to take away from this. Just remember a few simple principles. So simplicity is the key here. Simplicity helps everyone. It helps you develop the threat model, it helps people talk about the threat model, and it helps people read the threat model. Threat models have value only if it's easy to build, easy to talk about, and easy to read. If those things fall down because it's not simple, then you've broken it. So you need it to be simple where you can, obviously while reflecting reality. Number two is to use it to communicate. So if we go in with the mindset that it is a communications tool, then it's going to really help you with that simplicity and sort of communications piece, and sort of pitching it right for the audience. Some businesses are quite technical and quite involved, and actually they can handle up and down the management chain. They can handle more complex threat models. Some businesses are very much the other way. Technology is an addendum to what they do, and it might be core to what they do, but they, as a business, need to have that simplified in order to make decisions. Neither sort of model of business is wrong. They're just different. So make sure that you're thinking of your threat model as a communications tool and adapting it, therefore, to the people who are going to be reading it, which is not going to be just technology teams. And lastly, as I've already said, keep it up to date. Real word of warning here. Threat models that are not kept up to date, can really be an Achilles heel. We've come across customers where they have a threat model. They've done a threat model, they've ticked it off, and they've addressed the security question. Hurrah! Tap on the back, wave the flag, celebrate, brilliant. And then someone asks them a year later, so how about cyber? And they go, well, we've got our threat model. And they go, oh yeah, great, but it's a year old. Your threat model's a year old. You haven't kept it up to date. So you've now got two problems. Number one is your threat model's out of date, so you have to do it again. But also, and because it's so moved on, it's probably now more work to do. But also, threat models that are old can act as a bit of a fig leaf. They can make you think that you're more secure than you actually are, because they can misrepresent the risks to you. The risks that were there a year ago may not be the same as the ones that are there today. And that could be because of the attack landscape, but also because your business has changed. So really important to keep threat models up to date. It's just so much easier if you do. So that's me. I'm Johnny Tyers. It's been a great pleasure to speak with you. I hope you found the session helpful. ThreatPlane do training for dev teams who are interested to learn more about threat modeling and get a bit of sort of rigor and structure into it. So if you want to talk to me about that, please do. But what I would encourage everyone watching this to do is give it a try. Go and try, off of the material in this session, just go and try doing some threat modeling with your team. Choose some small feature or system in your organization and give it a go. Tell me how you got on. Drop me an email. My email address is here, johnny@threatplane.com. You can look me up on LinkedIn, just Johnny Tyers, J-O-N-Y, Tyers, T-Y-E-R-S. And yeah, I'd love to hear how you got on. If you're interested in learning more about threat modeling, getting into the detail of it, the grandfather of threat modeling is Adam Shostak, who is ex-Microsoft and is all-round brilliant. He wrote the book on threat modeling, which is now quite old, but still very relevant. So if you just look up Threat Modeling by Adam Shostak on Amazon. I'm not a salesperson for Adam or anything like that. I just think his book's great. I mean, it's what got me into threat modeling all those years ago. So yeah, a brilliant resource. But thank you very much. It's been an absolute pleasure. And hopefully I'll hear from some of you on your threat modeling exploits. So yeah, thank you, and hopefully catch up with some of you soon.